Today we're going to continue our lessons on factoring. We're going to start out by doing just a little bit of review on things that we've been working on before. Okay. First, this is when we were multiplying two binomials. We were using FOIL. So if you remember us doing FOIL, we are first going to multiply the first terms of each binomial, which is x times 2x, which is 2x squared. We multiply the outer terms, which is x times 7, which is 7x. We multiply the inner terms, which is negative 2 times 2x, which is a negative 4x. And then we multiply the last terms, which is negative 2 times 7, which is a negative 14. When we do this, we're always going to find like terms that we need to combine. So our final answer would be 2x squared plus 3x minus 14. One more example. Again, we're going to start with our first terms. Multiplying 3n times n would be 3n squared. Multiplying our outer terms, 3n times negative 7 would be a negative 21n. Multiplying our inner terms, negative 5 times n would be a negative 5n. And multiplying our last terms would be negative 5 times negative 7, which is positive 35. And when we combine our inner terms, we get 3n squared minus 26n plus 35. So that's just in way of review. We've also been factoring with a trinomial where the leading coefficient is 1. We have our invisible 1 there. And we were learning to do reverse FOIL with that. If you remember, you look at the last term, which is negative 32, and you would find factor pairs for negative 32. So you have 1 and 32, 2 and 16, 4 and 8. And you would try to find a pair where you add together to get a positive 4. So if we have this pair right here, negative 4 times positive 8 multiplies to get a negative 32, and it adds together to get a positive 4. So we rewrite this as x minus 4, x plus 8. Another example here, we have a positive 36. So we think the factor pairs for 36, 1 and 36, 2 and 18, 3 and 12, 6, oh, I missed 4, 4 and 9, 6 and 6, and we want a pair that's going to add to get a 15. So we look over here, see the 3 and the 12 add to get a 15. So we would have z plus 3 and z plus 12. So I hope that brings back to your memory the things that we were doing on factoring trinomials where the leading coefficient was a 1. Today we're going to be factoring trinomials again, but this time the leading coefficient, we call it the A term because it's in front of the first, it's the leading coefficient of the first term, is not a 1. So here are the steps that we're going to go through. None of these steps are new to you, but they are just putting some steps from several different things together. First thing we're going to do is multiply the first and third coefficients. That means the number from the A term, the leading one up here, and the last term. This is the C term. The first and the third coefficients are numbers. We multiply them together, and 4 times 15 is 60. 60 is now the number that we want to find factors for to do our factoring. So our second step is to find factor pairs for that number. So we think of 60, and we write factor pairs for that. We have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. We want factor pairs that make, again, this center term, the B term we call it. So if I look over here at my list, I see that 6 and 10 multiply to get 60 and add together to get 16. So we found the pair that we need. That was the third pair. Identify the pair. Now we're going to do a technique which many people call slide and divide. It's rewriting this trinomial as a polynomial with 4 terms. We are going to slide down or copy and paste the first term and the last term. So this is where they get the term slide. So if we just slide the 4x squared down, leave some space, slide down the C term. That's the slide part, copy and pasting the first term and the last term. For divide, we're dividing the center term into two terms based on the pair that we identified in the previous step. So the 6 and 10, we know that 6x plus 10x is going to multiply together to get your 60x squared, which is your 4x squared times 15 when multiplying the first term times the last term. And they add together to get 16x, which is our center term. So now we're going to divide this term into two parts, and we're going to put them here in the center. And you can decide which one you want to write first. You can either write the 6x first or the 10x first. Let's just write the 6x first. So I slid the first term down, slid the second term down, and I divided the 16x into two terms. Now we have a four-term polynomial that we want to factor, and we have been learning that when factoring with four terms, we solve by grouping, and that's what we're going to do now, and we've already learned how to do this. So now we take the first pair, we find the greatest common factor and pull it out, which would be 2x, and then what is left over is a 2x plus 3. We're looking for that magic, so over here we should also, when factor, get a 2x plus 3. If we look up at this pair, we know that if we factor out a 5 times 2x is 10x, and 5 times 3 is 15. And now you look for the magic. And so in factoring, the answer is 2x plus 3 and 2x plus 5. You have your two binomials. So no real new steps for you. There's just a lot of steps to go through in order to get to the answer. Okay, let's go to the next one for another example. Okay, again, we have a trinomial. The leading coefficient is not a 1. Our first step in factoring is always first to check for a greatest common factor. Is there a greatest common factor for these three terms? There is not. So our next step is to look that there are three terms. The leading coefficient is not a 1. So, as we've been learning, the first step is to multiply the first term by the second term, or you can just multiply the numbers. That would multiply to get a negative 24x squared. If you look at the numbers, it's 3 times negative 8, so we're going to try to find, this should be a negative 8 and a 24. They multiply to get a negative 24. So now we want to find factor pairs for a negative 24. So we have 1 and 24, we have 2 and 12, 3 and 8, 4 and 6. In order to get that negative 2, I see right here that if I have a negative 6 and a positive 4, they will multiply to get the negative 24 that we needed, and they add together to get the negative 2 that we needed. So we did step 3. Now we're going to do our slide and divide, which means we keep the first term, we slide down the first term, we slide down the last term, and we divide that middle term into two parts based on what we found right here. So we're going to have a 4x and a negative 6x. I think I'm going to group the negative 6x with the first one. You could do it either way, but I just choose to do it that way because I see that 3 and 6 have a common multiple of 3. So now we have our four terms. So here's where we factor by grouping. So we look at the first group and we pull out a 3x. And what is left is x minus 2. Over here, magically, we should have an x minus 2. And sure enough, if we factor out a 4, we have x minus 2 left over. So our final answer would be 3x plus 4 in one binomial and x minus 2 in the other binomial. So again, these are all steps that you've done before. It's just putting them together into one process. Okay, again, we always look for a greatest common factor to see if we can factor something out first. 2, 11, and 12 do not share a greatest common factor other than 1. We have 3 terms left. The leading coefficient is not 1. So again, our first step is to multiply the first and last together, which would be 24. So we want to find factor pairs for 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and we want to add together to get the 11x. So I look right here, and I know if I take a 3x and an 8x, they multiply together to get 24x squared. which is what the first term plus the last term equal if you go 2x squared times 12. That is a 24x squared. And they add together to get the 11x. So now we are going to do our slide and divide. We slide down the first term. We slide down the last term, and we divide the middle term into our two terms that we identified right here. I'll just do the 3x first. 3x plus 8x. Now we have four terms, so we do our factor by grouping. I can pull out an x. That would leave a 2x plus 3. So we know over here we're going to have a 2x plus 3. So I factored a 4 out because this would be 8x and this would be 12. And now we can identify our two binomials. We have x plus 4 on the outside, and then we have 2x plus 3 on the inside. Two binomials that multiply together to get that. This one's not on your notes, but let's do another practice here. Again, we have a trinomial. There is not a greatest common factor that we can pull out to start out with. So we're going to multiply the first term and the last term. That would be 30. So 30 is what we're looking for. If you just multiply the first term times the last term and you do 6x squared times 5, you get 30x squared. So we know when we multiply the center terms together, they need to equal 30x squared, but we're looking for factor pairs for 30. So we have 1 and 30, 2 and 15, 3 and 10, and we have 5 and 6. And we want to add together to get a 17x squared. So when I look here, I know that a 2x plus a 15x equals 17x. And when multiplied, it gets a 30x squared. So that's the pair I'm going to divide it into. So now we're ready to slide and divide. We keep the first term, slide down the last term, and we're dividing the middle term into two. I think I'll put the 2x, group the 2x with the 6x squared. And I'm going to group the 15x with the 5. Okay, now we have four terms, so we're going to factor by grouping. I can pull out a 2x. That leaves 3x plus 1. So magically over here, we should have a 3x plus 1. And I know if I factor out a 5, 5 times 3x is 15x, and 5 times 1 is 5, so that works. And so we have, oops, I didn't have it, pop it up there. In our final answer, we have 2x plus 5, and we have 3x plus 1. I'm going to stop there. There are more slides on this PowerPoint, but I hope that that gives you enough information so that you can factor by grouping today.